Imagine an ice-rocky visitor from another star system sweeping through our solar system but acting nothing like a typical comet. A celestial object so strange, it is forcing astronomers to question everything they know about what comets should be. That visitor is 3I Atlas. And what it is doing might be the most disturbing update yet. Stick around, because by the end of this video, you will be asking yourself, is 3I Atlas just a comet or something else entirely? First, some context. On July 1st, 2025, the telescope network called ATLAS in Chile spotted a new fast-moving object. That object was classified as 3I Atlas, the third confirmed interstellar object ever detected in our solar system, after 1I Oumuamua and 2I Borisov. Because of its hyperbolic trajectory and extreme speed, scientists agree that this comet originated from beyond our solar system. That alone makes 3I Atlas a priceless scientific treasure. We are getting a chance, perhaps only once in recorded history, to directly study material from another star system up close. And as it turned out, it does not behave like any comet we have seen before. Over the past few months, astronomers have pointed the world's most powerful telescopes at 3I Atlas, from ground-based arrays to space telescopes. What they found was bizarre. Using the ALMA radio telescope array, researchers detected methanol and hydrogen cyanide being emitted from the comet. Methanol is a simple alcohol, and hydrogen cyanide is a toxic molecule often found in comets. Even more shocking, the production rate ratio of methanol to hydrogen cyanide measured on September 12, 2025 was about 124 to 1, and on September 15th, it was about 79 to 1. Those numbers are among the highest ever recorded for any comet, surpassed only by a weird solar system comet called Comet Cs 2016R2. But that is not all. Observations from the James Webb Space Telescope revealed that the coma, the gaseous cloud around 3I Atlas, is dominated by carbon dioxide, with water, carbon monoxide, and other molecules present as well. And there is more. High-resolution spectra from the Very Large Telescope in Chile showed large amounts of nickel vapor being released while iron was nearly absent. That makes 3I Atlas extremely unusual compared to typical comets, where nickel and iron tend to appear together. Put together, this chemical fingerprint is messy, chaotic, and alien. Carbon dioxide dominance, an insane methanol to cyanide ratio, nickel without iron. It is like nothing we have ever seen. It gets even stranger. The ALMA data did not just measure the chemistry, it mapped it across space. And the spatial distribution is far from uniform. The methanol emissions appear enhanced toward the sun-facing side of the coma, while hydrogen cyanide is comparatively depleted on that same side. In simpler terms, the comet is not acting like a spherical snowball slowly evaporating. Different parts of the coma, the leading side versus the trailing side, are releasing different chemicals at different rates. This kind of hemispheric asymmetry is unusual. It suggests either a very weird internal structure, perhaps layers of different ices or materials that evaporate under different conditions, or something more exotic. Some researchers argue this could be the result of a crust formed over billions of years of interstellar radiation, burying older ices deep beneath the surface. When the outer layer heats up near the sun, only certain volatiles break free, causing uneven and irregular outgassing. What if 3I Atlas is not just a weird comet? What if its structure is more like a cosmic hybrid, a layer cake of different ices and metals, shaped by its long interstellar journey? Given how strange 3I Atlas has become, some scientists, most prominently Avi Loeb, have questioned whether it is purely natural. In media interviews and in preprint papers, they have suggested that some features might even hint at a technological origin rather than a simple comet. Here are some of the things that fuel that speculation. The extreme nickel vapor without iron is interpreted by some as evidence for exotic chemical processes, maybe involving unusual metal compounds rather than regular ice sublimation. The asymmetric outgassing and the odd chemical ratios might hint at a layered composition or at some kind of purposeful emission behavior. Non-gravitational acceleration, caused by jets of gas pushing the comet, and periodic brightness variations have been claimed by some to be too organized to be random natural outgassing. But here is the important part. As of now, major space agencies, including the United States Space Agency, have stated that 3I Atlas is a natural comet. So the alien probe theory remains speculative, controversial, and for many scientists, unconvincing. Yet, with each new odd data point, the pressure mounts. At what point does a weird comet cross the line into something else? So why does 3I Atlas matter so much? Because it might be rewriting our understanding of what comets, even interstellar comets, can be. If 3I Atlas is natural, its unusual composition could show that other star systems produce comets very different from ours, shaped by different conditions such as radiation, the region where they formed, and their age. That would change our models of planet formation and ice chemistry across the galaxy. If it somehow turns out to have non-natural features, that would be seismic. It would be evidence of extraterrestrial engineering or of natural processes we do not yet understand. Either way, it would be a paradigm shift. In practical terms, 3I Atlas offers a rare window into material older than our solar system. Some researchers suggest it could be around 7 billion years old, maybe among the oldest cometary objects ever observed. This is why space agencies, astronomers, and even international organizations are paying attention. Its passage is a once-in-a-lifetime event, and we are capturing as much data as we can before it disappears back into the depths of space. With all this mystery and speculation, there are some huge unanswered questions about 3I Atlas, and these are what we should all be watching. Is the asymmetric outgassing just a surface effect, or is it evidence of a fundamentally strange internal structure? The uneven methanol and hydrogen cyanide distribution could come from layered ice, dust, and metal structures, or from localized jets at specific regions. It could also result from a surface crust shaped by long exposure to interstellar radiation, rather than from the original makeup of the nucleus. What causes the extreme nickel vapor without iron? A natural explanation might involve sublimation of exotic metal-bearing compounds such as nickel carbonyl or similar molecules. But such compounds are rare, and the conditions needed to produce them are extreme. Could they form naturally in a distant protoplanetary disk, or is something else going on? Are the periodic brightness changes and jet-like outputs random, or is there an organized pattern that might hint at artificial processes? Some people propose periodic pulses or jet bursts. Others argue that this is just natural comet behavior under changing solar heating and rotation. Without conclusive evidence, we cannot rule out speculation, but we also cannot confirm anything extraordinary. How much of the observed coma comes from surface erosion versus deep interior sublimation? If 3I Atlas has a radiation-hardened outer shell, much of what we see may be only skin-deep and not truly representative of its original interior. That makes it harder to figure out where and how it formed. The bottom line is that we are still only scratching the surface, literally. If you are hungry for updates, here is what you should keep an eye on. Watch for the next spectroscopic and telescope data releases, especially from ALMA, the James Webb Space Telescope, and large ground-based telescopes. More molecular detections, or the lack of them, could push the interpretation toward a very weird natural comet, or something even more exotic. Watch for peer-reviewed papers. Many of the boldest claims, such as unusual nickel chemistry, layered structures, and crust versus core models, are still being tested. When those studies are fully reviewed, the scientific community will start to lean more clearly one way or another. Follow the light curve and outgassing behavior over time. If patterns repeat, that is interesting. If the outgassing becomes chaotic, that suggests natural disintegration or irregular sublimation. And pay attention to the tension between media speculation and careful science communication. This is a rare moment where science, mystery, and public imagination meet. Your voice actually matters here. So here is my question to you. Do you think 3I Atlas is a natural comet just shaped by extreme interstellar conditions? Or do you believe there is something more going on? Share your theory in the comments. Maybe together, we will be the ones to crack this mystery. 3. Atlas may soon be leaving our solar system, but it has brought with it cosmic whispers that could challenge everything we know about comets, planetary formation, and even life beyond Earth. Whether you think this is a freakish natural artifact or the first hint of something deeper, one thing is certain: the universe does not want to make it easy for us, and that is the beauty of it. If you find this as mind-blowing as I do, hit the like button, subscribe, and ring the bell, because once more data drops, I will be right here unpacking it with you. Until then, stay curious, stay skeptical, and keep looking up.